right, guys, so let's look at some of the questions that I got to cover as our exam 1 review and tutoring. So one of the things that I got asked about was figuring out these complex intake and output problems. So here's our problem here. I went ahead and drew out our chart just to save time. So let's, so first start off by reading your full problem. So after you finish reading that problem, then go back through and highlight the important bits. So starting with our intake, we'll do it in this blue color. So our lipids, giving 150 milliliters over 5 hours. We're doing continuous IV fluids, infusing at 50 milliliters. At 10, we get an order to increase that to 75. We're going to hold the fluids for 1 hour while we get 50 milliliters from 8 to 9. And the patient consumes 6 ounces of an ice pop. Now looking at output, we're going to highlight that in a different colors. We'll do this orange. So we have 150 milliliters of emesis. Emptied their catheter for 950 and empty 60 from the surgical drain. All right, so now looking at our chart. So we know that we're giving 150 milliliters of lipids over 5 hours. So if it says we're giving something over X amount of time, that means that they're still getting this volume. So we don't care about the time. So in whatever time we want, we'll write 150 because they're getting that. Now, IV fluids, because these are continuous, and we're starting off at 50 for our shift. And then before I finish filling out, let's read ahead to remind ourselves that at 10, we're going to increase it to 75. So at 10, I'm going to go ahead and write 75 there. And then before I fill this out, the last thing I'm going to look at is, am I going to be holding them at any point? And I am from 8 to 9. So I'm going to draw myself an X there so I know not to put anything. So then we're going to fill in 50 here, because at 10 is when we're going to increase them to 75, and that's going to be the rate that they're going to go at for the rest of our shift. All right, so now IV meds. We have our 1 gram of magnesium and 50 milliliters. This 1 gram is how much medicine is in this volume of fluid. We do not care about how much medicine it is. All we care about is our volume. So we're just going to put our 50 milliliters there. And then our 6 ounces that our patient consumes is going to go in our PO column. So our 180 ounces is going to go here. So now in our very bottom here, let's write up our totals of each column. Okay, so lipids, 150. IV meds are 50. PO is 180. So here in our IV fluids, we're doing 75 for 9 hours, plus our 50, plus our 50, so we should get 775. And now we're just going to add all of our totals up. So we should get an intake of 1,155 milliliters. And now for our output, we're just going to add everything up. So we should get an output of 1,160 milliliters. I think a lot of people were struggling with wording for these problems. So biggest things to remember, we'll come back to that screen in just a second. So if it says you're giving X milliliters over X amount of time. So like the case of our lipids, we were giving 150 milliliters over 5 hours. That just means that this 150 is the total volume they're getting over this period of time. That doesn't mean that they're getting 150 milliliters every hour for 5 hours. So some people would want to be like, okay, well, if they're getting 150 for 5 hours, I need to times it by 5. That's not the case here. So remember, if it says over, you're just going to keep this volume. Now, if it says, say, 75 milliliters per hour for something, then this means that you need to times it by blank hours, whatever your time is. So let's say that something says that the patient's getting normal saline at a rate of 120 milliliters an hour for the shift. Well, in this case, let's say our shift is 12 hours. Because it's 120 per hour, then we would times it by 12. So just kind of keep your eye out for those keywords. Over, you're just using this set volume. If it's milliliters per hour, then you need to times it by however long your shift is or the designated period of time. Now, the other thing that I was asked to work out was how to convert pounds to grams. So let's say you're working your test and you see this problem and you've studied your conversion sheet and you're thinking and you're like, there's nothing that specifically took me directly from pounds to grams. So you're probably like thinking, okay, how am I going to do this? Well, because you've studied your conversion sheet, you think, okay, I know that 1 kilogram is 2.2 pounds. And I know that 1 kilogram is 1,000 grams. So there's how I could get my pounds to my grams. So let's set up for our dimensional analysis. So we have our cross. Remember that our order goes on the left. So for this week, our order is what they give us. So 26 pounds. And remember what goes on the right is what we have available. So in this case, we have two things. We have 1 kilogram equals 2.2 pounds. And 1 kilogram is 1,000 grams. So remember to set this up in dimensional analysis, things have to be diagonal to cross out. So if I start out with 26 pounds, out of my two things that I have available, the only thing that I have that has pounds in it is 1 kilogram is 2.2 pounds. So think of these as it's a married couple, so they have to go in the same box together. But you can flip their roles. So our 2.2 pounds is going to be down here because they have to be diagonal to cross out. And our 1 kilogram is going to be on top. So our pounds will cross out. We're left with kilograms, which is not what we need to get to. So we know we use that. What we have left isn't what we need. So we're going to have to do a third column and use this other married pair from our conversion sheet. So 1,000 grams over 1 kilogram because my kilograms have to be diagonal to cross out. So all I have left is grams, which is what I need my answer sheet, what I need for my answer. So at this point, I can multiply across the top, multiply across the bottom. So 26 times 1,000 divided by 2.2 times 1. Okay. So 26 times 1,000 is going to give us 26,000, and 22.2 times 1 is going to give us 2.2. So now we're left with 26,000 divided by 2.2, which is going to give us 11,818.81818. Now remember, this grams is a weight, and remember that all of our weights need to be rounded to the nearest tenth. So this 1 is in our tenth spot, which means we're going to base this rounding on the 8. So our final answer is going to be 11,818.2 grams. So don't forget your rounding rules with these. And that is pretty much all of the topics that I got asked about to cover in this video. One thing I do want to remind everyone is of rounding rules. So remember that heights, weights, and temperatures all need to be rounded to the nearest tenth. Also, as a reminder, remember to put your leading zeros and don't forget to drop your trailing zeros. Other than that, just study those, watch the videos, and as always, send me any questions that you may have.